a seguir con las pláticas. Gracias por estar con nosotros. Ya prácticamente estamos en la recta final del evento. Y bueno, es el turno de Sandesh, que pues él trabaja para Oracle y nos ha acompañado en muchos de los tours y bueno, es un buen amigo de la comunidad. Le agradecemos que esté aquí. La presentación va a ser en inglés y bueno, el tema es sobre performance tuning en la base de datos utilizando Oratop. Thank you, Sandesh. We really appreciate your support in all these years for the tour, and we are very welcome here in the region, and we hope next year we can have an in-person event and you can join us as well. So thank you.
Yeah, this is great. Thank you.
Thank you, Sandesh. And I started the recording. Is that okay? Or do you want?
Yeah, that's fine.
That's fine.
Oh, no, okay. That's fine.
All right. All right. So you can continue, Sandesh. Thank you again. I'll be here checking the chat.
All right. Hola, buenas tardes, amigos. How are you guys? And so my name is Sandesh. I run a group in Oracle, basically working on AI ops, where we process machine data and come up with interesting analytics and stuff like that. But in the past, I've actually ran groups working on RAC, working on Data Guard. I've worked with support and worked on site at customers, worked on apps. So I have a wide variety of database experience over the last 20-something years. Today is going to be an interesting session, and this is going to be something that some of you have heard of and used, and some of you probably have never even heard of, but this tool has actually been around for quite some time. But I can tell you this, after today's presentation, you guys will discover the power of this tool and use it for a lot of performance tuning exercises that you're currently doing manually or using your scripts or any other tools. So what I'll do is I'll give you 2 minutes, and I want you to type in the chat, what are all the various things you do today for a performance tuning exercise? Like your boss comes and tells you the application is not working. What do you do? So if you can type in a few sentences over the next 2 minutes, what tools do you use? What scripts do you use? And how do you go about doing it in a few lines? If you can mention this in the chat over the next 2 minutes, that'll be great. Normally when you do this in person, it's very easy to talk to people. Now we have to do this via chat. But I want to see what you do today for performance tuning. Yes. Top DB events, great. What else? What are the other things what do the other people do? AWR, Ash reports, yes. What else? What more? Come on, guys, keep giving more answers. This is not the only thing. I can tell you when we did this in person last month, I got like some 35 answers. So every DBA had different ways of doing things, Some people had scripts, some people said enterprise manager, some people said AWR and Ash, some people said they log in and see VWR session underscore wait, Lots of people had lots of different things to look for when you're troubleshooting issues, right? Enterprise manager, ADDM report, keep coming. What else? What other things do you guys look at? So these are what, yes, traces, TKProf, excellent. So you notice one thing, right? There's different things that people are talking about. Some people are talking about database analysis. Some people are talking about SQL analysis. Some people are doing instance tuning. Some people are doing operating system level tuning, SQL tuning advisor. Yes, so basically trying to tune your SQLs, apply SQL patch plans, and try to see if you have optimal plans. Good, keep coming, keep posting different things, what you guys do today. So there's all these different levels of tuning. There's database, so there's instance tuning, there's database tuning, there is wait event-based tuning, and then there is SQL performance tuning. There are these 4 levels, right? So these are all the different things, and there's Auratop, of course. And so how many of you even know Auratop or have used Auratop in the past? If you say if you have used it, just give me a thumbs up in the chat. Or if you know about it also, give me a thumbs up in the chat. Good, heard but not used. Great. So I'll tell you this, okay? So here's a couple of things what Auratop is. So everybody has used top in a Unix environment or a Linux environment, right? Because what does top do? It shows you everything that's happening on the machine. What are the top processes? Who's consuming the most amount of memory? Most operating system, most tuning exercises, they always start with the operating system. They never start with the database, okay? Because the problem could be on the OS level, and you may be troubleshooting the database and there might be no answers inside the database level, right? So how do you see the perspective of the OS and then go into the database and then go into SQL and all of those things, right? So right now I'll summarize what all you guys have said. There's OS Watcher, there's AWR, there's Ash, there's ADDM, there's SQL Tuning Advisor, there's TK Prof, there is trace analysis, there's enterprise manager. These are all the different ways. So when I did this session last month in India, I got 35 different ways of analyzing the same problem. And these are all DBAs doing performance tuning constantly, right? So because we are used to using top for seeing operating system stuff, then came Auratop. So by the way, you only need to take a picture of this slide because I will upload the slides to this location here. So this is the only thing you need to take a picture of. And then once the presentation is complete, I will give the slides to the LAOC guys, as well as I will upload this to my slide share for downloading. So you don't have to take pictures of the entire deck, okay? And that's my Twitter and that's my LinkedIn if you want to reach me. So yes, so it's an interesting question. I use Auratop, but don't understand it totally. So after this presentation, you won't need a manual for Auratop anymore. This is a very simple presentation. It focuses on some things, but it also gives you the ability to troubleshoot and debug something from a holistic perspective, okay? So let's start off with this. Like, what is Auratop, right? So Auratop is a text-based interface. It's just like top, but it's a database interface which can be run against rack databases or single instance databases. And it also provides the ability to monitor the database in near real time. So if you're having some problem and your boss comes and says, hey, look at this thing for me, my application is running slow, you can quickly fire up Auratop and start looking at what's happening. The problem with all the other tools like Ash, AWR, ADDM is you have to take a report and then look at the report. By the time you look at the report, the system might have changed and you're no longer looking at the problem that you were originally looking at. So it's very important. It's like you're looking at a patient. You look at the real-time problem, what's happening with the patient, right? You look at the patient. You don't look at a report from 2 days ago as to what was happening with the patient. So that's why this is very important. It provides the ability to monitor this in real time. Now, this is sort of like what it looks like, okay? And there are 4 major sections to it. So first of all, let's get one question out of the way. Where is this available? Where do I download this from? You don't have to download it. It's in your Oracle home right now. So it's already installed. You don't even know it's there. So just search your Oracle home for Auratop and you will find it. And you can call it directly from there. It is available since 11.204. So even if you're running a version that's as 10 or 15 years old, you still have access to this utility. So a lot of people are like, oh, but this is a 23C or a 21C utility. I don't have it. No, this utility is as old as 11.204, and it is available from every version since then, all the way to 21C right now, okay? The only difference is that every version adds a new feature. Like, for example, when we started coming up with 18C, we added PDB support, we added data guard support, we added rack support about when we were in 12.1, 12.2. So we kept adding more features in this, okay? So this tool is already present on your system and you can use it today. So once this presentation is complete, you just take these commands and you start typing them on your machine and you can start analyzing these problems today. Second, there are 4 sections here. There's the database section, which is basically this top section here. So there's this section here. Then there's the instance section, which is the second section here. Then these are all the events that are happening. And then you have things like how long these events have waited, what's the total time, what are the average waits, what percentage of the DB time that has been spent in this specific event, what wait classes these events are running on, How much PGA am I consuming? What is the total memory size consumption I have for this? What database version am I running? What is the percentage of CPU consumption for this instance? If I have multiple instances for the same database, I will have another instance here. So you'll see another line here with another instance and all the information about it. What SQLs am I running? What is the SQL ID? What are the CPU consumption for this? What is the events it's waiting on? And how long have the total wait events being waiting on for this particular thing? So it shows you a lot of information. And this information is constantly refreshed every 5 seconds. There's a way to change that also, but usually you don't need to, because anything more than 5 seconds, it takes you 5 seconds to just look at something and analyze it. But this is a pretty cool user interface. It shows you how long it's been up, shows you a whole bunch of instance stuff, shows you a whole bunch of database stuff. So that's pretty cool. Okay, so this is great. So now that you will find Auratop in your path, it'll most likely be in your path. When you do an Auratop -H, it shows you all the various options. Now, you might think there's so many options here. Which option should I use? Which option should I not use? It's not that complicated. There are a couple of basics you have to remember with Auratop. First of all, you can connect to Auratop where you can connect a sysdba, or you can actually create a role where you can assign, I think it's like connecting a dictionary or something like that. And it gives you a basic set of dictionary access. So Auratop does not write anything to your database, okay? It is a purely read-only utility that requires access to $V views to pull all this information. The utility itself is free and it's part of the database, okay? So you can use this right away. The couple of options here. There's batch mode, which is a text-based mode. And I'll tell you an example of why you want to use this. There's iterations of how many times you'll go through this. Then there's a real-time versus cumulative mode. There's a SQL mode, and there's a detailed mode. So these are, once you start using this, it'll take you 15 minutes to start using it. It'll probably take you another 30 minutes to get used to the keys. And then you'll be on your own. You don't need a manual for this thing. It is that simple, okay? So you connect to this. I'm connecting as sysdba, but you can create a user and you can connect to that less privileged user by just granting a specific role. Now, for this, by the way, if you have any questions while I'm going, just type it into the chat as I go, okay? So when I stop, I'll address all the questions and I'll continue to the next point. So as you have questions, as I'm going through the screens, please type the questions into the chat. So I'm connecting as sysdba, but you can connect as a far less privileged user. If you're connecting remotely, you'll obviously need the remote login password file available. Now, why would you connect remotely? This is a Linux-only utility. It's not available on other platforms. But does this mean that you can't use it for an AIX database or an HP or a Solaris database? No, you can use it. Only difference is you have to connect to that thing remotely. So there's a variable here called toTask. You can set this to the host, the port, and the database, and it remotely connects to that database instance. Or you can basically use Easy Connect, one of the two. And this will connect to your remote database, which is running on a non-Linux platform. And you can view and you can do everything that you can do on a Linux platform. So the only thing is, this is a pure SQL interface for connecting to a database and viewing all sorts of stuff inside it. Okay, so this is really, really powerful. Once you realize that you don't really need anything, you don't need any drivers, you just connect and you're done, right? So this is the key. This is the screen that you need to take a printout of and stick it near your desk, because this has all the keys. Now, I found that after using this for 2 or 3 days, I kind of by-hearted the keys. It becomes muscle memory, okay? Because you toggle between standard and detail mode is F, you toggle in R is real time, S goes to SQL mode, P switches from switches between a session and a process mode. And then if you were running this against a apps database, then you want to see more module action instead of username program, because you want to find out which module or which module action is correspondingly causing these performance issues, right? So you do this. Tablespace information. So you do tx shows you SQL plan tables. What is that SQL running? What's the plan of that particular SQL that's running inside of that particular instance? So the cool thing about this tool is you can do all of this without leaving the tool. So if I'm doing the traditional performance tuning and I have scripts, right? So I found something on vroller session underscore wait, and I go find that, and I find, oh, this is the session ID for this thing, and then I go and I run another SQL. Oh, that's a SQL ID for that, and I run the SQL and pull the SQL information. Then I run UTL explain plan and I pull the plan table. Then I go back to my script. There's a lot of back and forth. I don't have to do any of this with Auratop. I just go click, copy, paste. I can see the plan. I can go back to the troubleshooting. That's why this is a really, really powerful tool for people to use. You can change the refresh interval also. So I also put a couple of symbols out here. So if you want to know what B, K, M, T, and all these things are, this basically is a nomenclature for what is displayed in the tool. You know, what's micro, what's milli, what's seconds, minutes, and all that sort of stuff. And these are the 4 abbreviated sections, which I'd shown you in the first screen. So now let's go into a little bit more details of what can you do with this, right? Now, here, anything that appears in red needs an attention. It's a warning. It's like, so the tool has a certain set of smarts inside it, where it looks at some of these values and says, this value is not right, or this wait is too long, or this session is blocking too many sessions, right? So all of this stuff, it causes all sorts of problems, okay? So it knows that this is going to have a problem. Is it an immediate problem or something that might become a problem later? Or if it's a completely idle instance, it will show you the top wait event that's in that idle instance. And you can see the instance is idle. So if your SQLnet wait from client is the only wait event there that's in red, like it was in this previous screen that I showed you here, that means that this is an idle instance because there's nothing happening there. That's the only wait event on this particular instance. So there's a whole bunch of internal SQL, but because 93% of the waits on the database is SQLnet more data from client, it's an idle instance. So I can quickly make an analysis just by looking at these things. But just remember, red means you need to look at it, okay? And that's sort of like the message here. There are 2 headers that are archive log and ER incidents, and these are static. They're only acquired when you start the monitoring session, but they don't auto-refresh because they're expensive recursing queries. And they also add to diagnosability wait events. So if you see those 2 values in the headers not changing, that's why it is. In the second section, there's this thing called the percentage DCP, which is very interesting. It is the database CPU, instance CPU consumption as a percentage of the host consumption. So I can see how much is this database consuming when compared to the entire machine. So it's a very interesting perspective, right? Because when you're performance tuning, you're looking for 2 things. One, is this consuming more resources on the machine than what it's supposed to? So if I have 3 databases, is one guy taking all the resources? Or the second kind of analysis is within a database instance, I have contention. Is a SQL blocking a SQL? Or is this database not switching archive logs really fast? So that sort of stuff works. I have a question here: from what version of Oracle database does Auratop work? Starting 11.204 onwards. I've also tested this with 10. It does work, but there's a lot of views underneath that don't exist. So if you use a new version of Auratop against an older version of the database, it may or may not completely show you all the values, because some of the things at the back end won't work. The values won't be populated. But the utility will pretty much work with everything. Okay, so this, like if you connect a new version of Auratop, it'll look for PDBs, it won't find PDBs, it'll show nothing in the PDB section. So expect some columns to be blank, but the utility is shipped since 11.204. So you will be able to use it since 11.204 onwards. So this percentage DCP column is very important. And because it shows you what percentage of the overall system CPU this database is, it gives you an idea from a sizing perspective, how many more databases can you put on this machine? based on its consumption, right? Or if this guy used to consume 40% of the resources of the machine and now they consume 60, you know that something has changed and something needs to be done. Either you can move some database out of the machine, or you reduce you play with resource manager and you reduce the total amount of consumption, or you change the CPU count inside the resource manager so that this guy does not consume more than this much CPU. You can do all sorts of interesting things with the database once you realize what its total host percentage CPU consumption is. So this is one thing I use very heavily when I'm looking for problems. You can also look at all the table spaces. This shows you from all the CDBs and the PDBs, and then you can toggle between cumulative and real time. So this is the detailed format. Now the detailed format, as you notice, is much longer. There's a whole bunch of more stuff out here, okay? Now, initially, all this might look really confusing because there's a lot of stuff in this thing, right? It's like, okay, what is this or what is that? Like some of them are obvious, right? This is the redo generated by this instance since startup. But it's very useful to know these values, right? Like what is the total PGA consumption, right? In this particular instance, right? What are the number of IOPS? What are the megabytes per second, right? What is the IO rate? So these are all the average active sessions, right? How many average active sessions are having contention? All these are shown here. So within a couple of seconds, this is a summary of all the average active sessions. We'll get to what these are in a bit, okay? But it shows you a much longer section and shows you a lot more data here in the extended mode. Another thing also is the extended mode also shows you more data at the bottom, okay? So in the earlier version, you saw there was probably just the SQL ID. Here it even shows you the wait event details of the SQL IDs. It shows you a couple of extra columns here, like percentage CPU was there, but LIO wasn't. It also shows you what wait events these are. It shows you a little bit more about the service. This was not there. So there's a couple of new columns that it shows you. And these are the instance and the SID of that process. This is the process SPID, which is the PID on the operating system side. So within a couple of seconds, you can find out if any of these guys are blocked by any of them because it will show them as waiting, right? It will show roll-off contention and all that. It's very, very easy to spot a blocker in this view, okay? But this is a detailed view of the whole thing. Now, why would you use batch mode? Now, sometimes we want to go for lunch and your boss tells you, hey, there's a job running and keep an eye on it. But Auratop is an interactive utility. It runs and you are supposed to look at it. That's where it's most powerful, right? But what if I have to go to lunch for 30 minutes and come back, but I want to keep an eye on the job? So I run this in the batch mode. And what this does is every n number of seconds. So I can configure how many times to run. I can say, run it for, say 30 minutes. So run it once every minute for 30 times. And every time it will take a snapshot and write this to a file. Now, what does this have? The same thing. It has all the database. These are database statistics. These are the instance statistics. These are the wait events, and these are the sequels. So it has all of this, and these are waits that are happening at that time the snapshot is taken. So once you run this and you go have your lunch and come back, you have 30 snapshots to look at. And you can quickly look at this and see if there was anything that was potentially stuck from a perspective of what's happening with this system, right? So this is a very good utility to monitor a job when you're not there. And it takes screenshots of these things and puts them down, and you can just look at the cycles. So each of the cycles will be labeled as cycle 1, cycle 2. So you know you're looking at different cycles when you are analyzing this output. But this is really, really powerful that you can look at this in a batch mode, okay? So by the way, once I'm done with this presentation, you don't need any other training manual apart from this presentation. And I'll show you why later, because everything is documented in this presentation, okay? You just need this presentation to play around with all the options that are present with this thing. You don't need to read the user manual. You don't need to go to Moz. You don't need to look at Google and nothing, right? So this is a batch mode, and this is why you would use it to monitor the database when you're not there for a job that you know is going to run for a certain moment in time, right? Now, I want to look at this, and this is normally I do these exercises with my class, right? Is look at this particular screen, and what do you think is happening on this system? If I'm looking and analyzing this, what are the various things that you can see on the screen? And please type it in the chat that is happening on this system based on these wait events and based on these stats. What do you think is going on? A session is blocked, okay? What else? What else is happening here? To answer the question, do I have to install Auratop in the same machine where the database is running? So Auratop is already installed in your Oracle home. But once you specify the Easy Connect DNS Connect string, you can connect to any database anywhere using that. Session is waiting on log file sync. By the way, if you don't know what log file sync is and you're a DBA, you have been sleeping. You have to know what log file sync is, okay? Because every DBA knows what log file sync is, and it's a major wait event, and there could be bugs on log file sync, but it could also be a genuine wait event where there could be a problem on writing log files out. 2 instances trying to read the same block, really good. Come on, keep going. I like it. You guys are, see, I'm not teaching you anything. I'm just showing you a screen, and you see how quickly you're using your knowledge and your experience and coming up with answers, right? This is why this is really cool. Okay, there's a lot of commits happening per second. Great. Keep going. What else do you see? After commit, session is waiting for log buffer to flush to redo file. Yes. You're absolutely right. This performance affecting log file. Yes. Keep going. You guys are on a roll. Why do I see 2 SQL statements here, and they kind of look like the same because they have the same SQL ID? Too many commits or redo log files in a slow device. Possible, very possible. I like it. See, I'm not even telling you guys what this is, right? But you're looking at this output and coming up with this. This is what I want you to learn. I want you to use the power of the information in one place, right? And you can quickly decide, hey, what's happening, right? Lack of indexes, yes, possibly. But also when you give a suggestion, also post why do you think that's the case? 2 sessions doing the same select on both instances. That is absolutely correct, Vitek. And that's what. And how do you know this? Because there are 2 instance IDs here. See, this is what I'm trying. I'm trying to just show you something, and you don't even have to learn Auratop. You already know how to use it. So what else do you think is happening here? I mean, is there CPU contention? Is there memory contention? Is there any of those other kind of things? Is this a system load kind of problem? What do you guys think? I mean, look at all the values. What makes you think the load is high? Because of this? Okay. So do you want me to give you my perspective on this? Now, look, there's no right or wrong answer in performance tuning, as you guys know, right? Because everybody comes through a different way, but eventually people find, they kind of find the answer and they figure out what's going on, right? So yes, so log file sync is important, excess commit is important. So I'll tell you what's happening here, okay? So first, there's a bunch of selects. There's a very good chance that this delete is happening on the same set of blocks from which the selects are happening. As you can see, there's not much happening from a rows perspective here, but this select is causing some load. It's taken forever to run. But the percentage DCP, which I just showed you, which shows you the percentage of the host consumption with respect to each database, is not that significant. If I look at any of these, it doesn't look like any CPU contention is going on because the total DB CPU itself is 23%, but there's a lot of contention when something in the database is not moving. I see two weights here. GC current block busy, and I see GC buffer busy acquired. Now, GC buffer busy acquired is a wait event in rack that indicates I can't pin a buffer. Okay. Now, when I can't pin a buffer, that basically means that somebody's either using that buffer. So it's the buffer cache change latch for that particular buffer has been held and somebody's making changes to it. The GC current block busy is the wait on the other side of the rack instance that says, hey, can I have that block? And the guy says, oh, the block is busy, come back later. But here, so I'm having multiple people accessing a single set of blocks across machines. And that's what these two wait events are. Now, while this is going on, it's not exactly remastering. There's no remastering going on. But what is actually happening here is the blocks, when you're making a change to a block, you have to write the redo that corresponds to that block first. And then the exclusive copy of the block has to be transferred, and the whole lock table has to be updated, indicating now that client has exclusive access to this particular block. If you have a large number of rows in the same block and you're running into ITL contention when you're writing it, or you just have too many sessions updating the same block, then that block is going to ping pong between rack instances. And that's basically what's happening between these two wait events. The reason the log file sync is showing up is because the exclusive block has to be committed before it can be shipped to the other node, and then the other node makes changes and it commits it, and it has to be shipped back here. That is causing a log file sync wait event. Now, log file sync can be because of a lot of things, right? So you don't remaster. So most logs are never remastered unless you're doing something called DRM, right? So when you're using DRM, where if a block is accessed more often on one machine than the other, than it was originally mastered on. So say a block was mastered on machine 1, but it's always accessed on machine 2. After some time, the DRM system will look at it and say, maybe I should just move the master to this guy. That's lock remastering, okay? That usually does not happen in this case because you're having a case where a block is constantly moving between two systems. So it's not spending enough time to establish locality in one instance for it to move the master. That's why there's a difference between shipping exclusive blocks and remastering the block. This is not remastering. This is shipping the blocks between their systems because they're trying to access the same thing. The delete is probably trying to access the same block. The log file sync could be just contention, could be a bug. There are a lot of bugs on log file sync, and usually you have to apply a patch to fix it, or could be it's writing to the disk. It may be slow. But also, if I see other things, I will also see a log file parallel write wait event. That will indicate a slow disk, because if I'm not able to write the log files fast enough, this could have a data guard environment. It might be sending logs to a remote node, and that's probably why I'm having log file sync related issues, right? So the conclusion is I'm having massive contention and commits happening on a small set of blocks that is shipped between two rack nodes. That's causing row lock contention. Well, if you have buffer busy acquired, you're going to have row lock contention, right? Because you can't gain access to the buffer in order to access the ITL to make the changes in the rows inside a block, right? So this is a side effect of the contention. And the log file sync happens to be there because you're continuously committing the block when you're shipping it between rack nodes. And this is happening across both rack nodes. The selects and the delete is only happening from one of the rack nodes. The load is there, but it's not significantly high enough to actually cause a problem on the system. But you see, right, just looking at this, how much information and analysis you can do just by looking at a single screen of Auratop without running scripts, without looking at all these other things. Was this fun? I mean, do you guys like this? I mean, this gives you so much perspective without running 10, 20 scripts and setting up anything. So that's what I want you guys to learn. Okay, let's look at something else, right? So I have a SQL, right? and I look at this. So I want you guys to be smart DBAs. Okay. So tomorrow when your boss calls you, you have a very, very different perspective and you're really, really fast at getting this information and analyzing. That's the goal of this session, is to make you guys really, really sharp in using your experience that you already have and an interface that you can already use and give faster answers to your bosses. That's what this session is doing for you. So if I go here, I can actually go to this and I can enter a SQL ID, right? So I look at something and I'm like, what's going on with this SQL, right? I can enter a SQL ID and the plan is automatically shown to you. So I don't have to leave the interface in order to look at the plan, which is kind of really powerful, right? Because earlier I have to do this manually. I have to run an explain plan utility. I look at this thing. I don't have to do any of this stuff anymore. I can just go here, press X, put the SQL ID, copy, paste, done. I can see the current plan. This doesn't show you the historical plan. So it shows you the plan prior to execution. So the plan might have changed. Could it have changed? Yeah, it could have changed. But this shows you what it gets from the plan table anyways, which is what you would probably see. Otherwise, we got to go read all SQL execution and look at all the previous plans. But this shows you the current plan, right? This is just the explain plan. This is just the explain plan. It's not the real and final plan. In some cases it could be, but you won't know that. But it gives you the same thing that you get from an explain plan table. All right. That's a good question. Actually, so I have an enhancement open for this where we actually reflect the real plan by querying the views. See, one of the problems always is, if you have a lot of queries against the SQL area, you're adding to the contention of the system. So this utility is very careful in only accessing those $V views that don't access and add to library cache mutex contention. Because if I query $V SQL all the time, I will add to the problems that's happening in the system and I will slow the system down because I'm continuously querying the SQL area, right? So I can't query the dictionary without causing problems in the dictionary if I continuously run queries every second. So that's why these things are very carefully designed to allow you to analyze the problem without looking at or without causing any other problems within the database system. So this is the explain plan. Couple of things. To quit the program, it's pretty easy. You just use a Q or escape C. Even if you do a control C, it still performs a proper database logout. So we don't leave any zombie connections and any of that stuff flying around, okay? No matter what happens. If you connect using a non-privileged user that does not have access to some of these underlying $V views, then you basically get this table of view does not exist, and you have to grant the appropriate privileges. You can do grant, select any dictionary to that user, to a non-privileged user to use Auratop if you don't want to grant DBA. So they just need access to the dictionary. You can further break this down and just grant users to certain specific views. I know some people who have done that, and that allows you to run the utility in a much more degraded fashion. But as a DBA, you can create an Auratop user and you can just grant select any dictionary to that user and you can use that to monitor. Some cases when you do this, it doesn't return any rows. There's a bug for that. It's a pretty old bug, but some people still get affected by it. If you connect Auratop to a mounted instance, the instance is not open, it will only show the instance ID highlighted in red because the required statistics are not available until the instance is opened. So when you see an instance ID in red, means that database instance is mounted but not open. So we don't have access to the $V views that we need to get all the statistics from that particular instance. That is the same case if you're running this against a standby database, because a standby database is constantly mounted when it's actually applying video logs. If you want to monitor a local database, you can just do Auratop -i10/assistdba. This is how you monitor. If you want to monitor a remote database, you will just give it the TNS alias, and it will monitor a remote database for you. This is how you monitor a database every 10 seconds. You can run this from AHF. As you know, AHF ships a whole bunch of utilities, and we basically have a menu you can run this command called tfactl menu, and then you basically pick system analysis. By the way, I know a lot of people don't even know about this utility, so just play around with this. You'll find a lot of tools and scripts that you probably never knew that existed, and you can actually play with some of this stuff. So if you want a summary of what's happening on the system, if you want a list of events that are happening, you want to analyze the logs and look at a summary of the logs, there's a whole bunch of stuff here. So I go into TFA utilities, and I go to the next screen has a whole bunch of AHF tools. So everybody knows what Auracheck and Exacheck is. If you don't, you've been living under a rock, because Auracheck does all sorts of best practices on a regular system, and Exacheck does best practices for an Exadata system. The utility we want to run here is Auratop. So it will find the utility and execute it for you. If you have a 2 GB alert log, and your boss asks you what was happening with this alert log, and you're like, I'm going to look at 2 GB of alert logs, you can run alert summary, and that will summarize the 2 GB log to like 2 or 3 pages, and you can see everything that has happened in the system. You can purge your logs using manage logs. You can look for parameter values using param. So I can say param db file multi-block read count. It will give me the value of that parameter across all databases in the cluster without connecting to every database and running a $V parameter. I can do pstacks. I can view tail. So I can say tail alert underscore, and I leave it. It shows me the last 10 lines of every alert log from every database from the entire cluster. So there are a lot of powerful utilities inside AHF that most people don't even know about. But anyways, so this is how you can access them. But you pick 2, which is Auratop, and then here you have the command that it executes, where it says Auratop minus database, and it basically connects to that particular database. So you can use either AHF to do this, or you can directly connect it using the utility, whichever works for you. This is the difference between standard and detailed mode. We spoke about this, but I wanted to put these two things side by side to give you an idea. There's a lot more columns. If you're looking for weight and contention, you basically look at all these areas. If you look at memory consumption, all these are IO consumption related. Sorry, even this one, some of this stuff here. Some of these are memory related. So I have labeled what these are. So it makes a very easy way for you guys to go between these things. But this is the difference between standard and detailed mode. This is the difference between cumulative and real-time mode. Now, this is the same instance, except the wait events and everything else are very, very different, okay? Because you're looking, see, the top, this section is going to be pretty much the same, because even if you're monitoring it real time, it'll still show you cumulative stats. The interesting part that changes is this part where the wait events are, and this part where the SQL IDs are. Actually, even the SQL IDs don't change as much, because it'll show you what's happening in real time anyways. But the wait events change because, so what is a cumulative mode? The cumulative mode shows you the wait events from the time the instance was started. This shows you wait events that are happening right now in the system. So if I look at this, it just looks like a bunch of parallel query slaves that are running across nodes. That's all that lower set of wait events is. But if I look at the top set of wait events, what can I conclude? Well, why don't you guys tell me, what can you conclude from the top set of events? Let's do this again. Let's exercise. Type in the chat. What do you guys think is happening in the top output? Look at the wait event descriptions and stuff like that. Tell me what you think. The lower part is not interesting, because it just tells me there's some control file read, there's a PXDQ, that means parallel query is kind of running. There's a PS contention, that's an NQ for parallel query. There's an IMR slave acknowledgement, that's okay. There's IPC send sync, which is because the inter-instance IPC can connect between the two nodes, right? So this is obviously a rack instance. So I'm probably doing PQ between the two nodes, and that's what that is. But what about what's happening here in this top section? What do you think is going on with this system? Come on, guys, you're faster than this. You should already know the answer for this. Average wait event for log file sync is this, which is very high. Yes, it is. But there's more going on than just log file sync. Look at the other events. This is actually a very simple one. I'll give you a clue. The database wait is hardly anything. And there's a lot of this. Redo log file sizes need to increase. Yes, that will temporarily alleviate it, but eventually this contention will come back. So does everybody know what checkpoint incomplete is? Or can someone tell me what checkpoint incomplete is? Why would you get a log file switch checkpoint incomplete wait event? The keywords I've highlighted will tell you exactly what's going on here. No takers? All right, so let me give you my perspective on this. So first of all, the log file switch completion, right, happens when you try to jump through different redo logs, right? And yes, so Jamshed has explained this. DB writers need to write the files in this. Log switch is waiting for checkpoint to complete. So why do we do this? Oracle is a log ahead protocol database. To preserve read consistency, we always write the change to the redo, and then we write the changes to the memory, and then the DB writer writes these changes down to the disk, and the checkpoint says all these guys are done, right? While you're doing this, okay, if the blocks that correspond to those redo changes are not written from memory to disk, then that redo cannot be overwritten. So if I have 3 redos and I go back to overwrite the first redo, and if changes that correspond to that first redo are still in the memory for the buffers, the buffer cache, I have to write that down before that redo is overwritten. Why is that? If the changes are not written and I overwrite that redo and the instance crashes, it will come back up and it will try to find those buffers that were in memory that were never written out, but that will never be recovered because that redo is gone because it was overwritten. So until every last buffer, or what's called the RBA, or the redo byte address, there's a queue inside the buffer cache where all these things are lined up. Until that RBA, everything has to be written out. The DB writer does that. So if you're seeing write completion waits, the database writer is having problems writing things fast. You see log file sync, right? And then you see log file switching completion. So basically, the whole database is sitting on a really slow disk. I hardly have any MBPS. I'm having a decent set of IOPS, but I'm hardly getting any MBPS here. So the wait times are significantly higher for IO. So this is an IO wait event. This is an IO wait event. This is an IO wait event. This is an IO wait event, or at least related to an IO wait event when you look at all these things. So I need to figure out why my checkpoint and DB writer are not writing buffers out quickly enough. And that's why the entire system is hanging when the log file switch completion checkpoint incomplete wait event happens. If you add more redo log groups, then you just extend the problem. You're giving it more time to flush the thing down. But if that time is not enough, so this only happens if you're switching very, very quickly, but you're not generating enough redo either. So, I don't know whether increasing the redo would have actually fixed this. But there's no right or wrong answer on this, right? I'm just telling you guys, you figure out your analysis. You can make a hypothesis and then look at the remaining pieces of data and say, oh, this is correct or this is not correct. You can go back to your scratch and start analyzing things again. That's why this is very, very powerful. All right, let's do a couple of things. We are actually heading towards the end of the session. I'll show you a couple of more screens and then we can open it up for questions, okay? So you can toggle this. You can go to module actions by doing an M that switches the thing from program and user. You can see table space information, which is kind of really easy. You can also see SQL plant tables. This is what we did. We did X and you take a value. You can also change the refresh interval. By default, it's 5 seconds. and there's a help. But the most interesting one is I actually spent some time doing this. Now, this is what will be very, very useful for you after this presentation is complete, because everybody looks at the help and you're like, I look at the help and what do I do, right? So now I just have to have this open and you can see what role the database has. Is it read write? What's the name? How long the database uptime has happened? How many instances? How many PDBs? What is the active number of diag counts? What's the size of the database? It's 35 gigs, SGA size. What's the flashback recovery area percentage? And archive or no archive log mode, as well as what the database utilization is in terms of how busy it is. So I spent some time making these 3 slides, which I thought was very useful for looking at different perspectives of, hey, what is all these numbers and letters and all that, right? So if you see this, it gives you in a couple of seconds a good idea of what each of these values are and what you can do with them. All right. I did the same thing for the SQL session. So this is slides for your reference later when you are using this to use and you're troubleshooting these kind of things and stuff like that. Yes. So here's another question is average active sessions, right? Average active sessions is the same thing as what we know, right? It's ASH. The only difference is instead of actually connecting and doing $V session weight and looking for some of these things, there are 4 values here that you can look at. So one is the average active sessions, which shows you how many active sessions do you have, how many of them are on your CPU, so ASC, and then how many are waiting on IO. The most interesting one is these 2, ASI and ASW. ASI shows you sessions waiting on IO, and ASW shows you just sessions that are waiting, most likely for CPU or something like that, right? And then you can, if these numbers are high, then you have a lot of blockage in your system. You don't even have to do, select blocking session from $V session wait where session ID equal to this. You don't have to run any of that stuff. This gives you a database level view of ASH by showing how many sessions do I have, how many of them are running on the CPU, how many of them are waiting on IO, how many of them are just waiting, how many of them are inactive. Like, can I kick some users out of the database by just killing them? That's why this section for me is very important to get a perspective of what the workload inside the database is like without actually having to look at anything else. I would start with this, and then I'd go to load, I'd look at CPU, I'd look at wait events, I can look at redo generation. If I'm running a rack, I would look at how many global cache blocks are received. If I'm looking at memory issues, I'll see how large my PGA is. So these are things that you can quickly start looking at when you have some kind of a performance issue. If you start using this for a couple of days, you'll automatically be wiring yourselves to look for the right thing, and you're in like 90% of the time, you'll come up with the right conclusion of what is happening inside your database. There's one huge limitation of Auratop. It connects to one database at a time. So you can't, and it's not like Enterprise Manager that shows you all databases and happening everything. The DCPU gives you a perspective of how much contribution this thing is doing to the system, but it does not give you any more perspective than that. So this is a single database at a time analysis utility. Now, nothing stops you from having 2 screens and running 2 Auratops on 2 simultaneous databases and comparing them and looking at which one's actually causing a bigger problem on the system. But it is still a database level, a single database level utility. So if you're looking at a rack cluster, it shows you all your instances. But if you have, like multiple databases running on the same rack cluster, then you'll have to have that many number of Auratop user interfaces to monitor them. So it doesn't give you a machine level perspective on everything, but it gives you a full in-depth drill down of what is happening inside your database instance. With that, I think I'm done with my slides. If you have any further questions, go at it, guys. I think we have maybe 5 minutes more. Thank you, sir. Thank you. It's always a pleasure to see you guys. And by the way, thank you for being active. Okay, I mean, I really appreciate you guys giving your input. See, this is what makes a session more active, right? It should not just be like, hey, I'm talking and you guys are just listening, right? It's like we're all being more active in participating. When I do this thing, actively in person, it's way more enjoyable than doing it on this. But we are limited by this, so I hope you guys stay safe. If you have any further questions, we have another few more minutes if you want to throw them. Thank you so much, Rita. Good to see you online. I hope we can meet up in person sometime somewhere in the world. Let me go back to first. So this is where you can follow me on Twitter if you want to connect and ask more questions. And if you want to download these slides, I think by the end of today, I will upload my slides to this location. So you'll get my slides. Rolando, I will send these slides to you as well. So you can upload and share them from LAOEC as well.
Okay. Thank you, Sandesh. And there is Jamshir is asking how IOPS.
One is IOPS, and one is the throughput, like megabytes per second is throughput. One is IOPS. IOPS tells you how many IO operations per second you're doing. So in other words, if I'm eating food, one is like how many times you can move your hand fast, and the second one says how many kilograms of food are you eating. So that's the difference. So one talks about the number of IOs you're doing. The other one talks about the number of IOs multiplied by the individual consumption per IO. What is the overall throughput? So IOPS will be, I do like 25,000 IOPS a minute. And the other one will say, I do 5 gigabytes per second or whatever. So it's like, so one is a count of how many number of IOPS you do. The other one is a count of how many megabytes per second in terms of throughput that you use. They are both IO markers though. So usually they will be correlated. Yes. Usually read. Because you're usually going to read something and then you're going to write into it. Write contention will manifest itself in different ways. You'll see other database wait events. So this is purely a measure of how much data you can put into the database and pull out of the database. That's all it is. That's what throughput is. All right. Thank you so much, guys. It has been an absolute pleasure. Thank you so much, LAOEC, for giving me the opportunity to present this. You guys rock. I hope we see you in person. And until next time.
Thank you, Sandesh. It was a pleasure for us, and see you. Thank you. Bye bye.
Thank you.
Gracias a todos. Hasta luego.